Hi, I'm Mark Loux, Extension Weed Scientist at The Ohio State University. It's July 2021. I'm standing in the middle of one of our herbicide screens at the Western Research Station in South Charleston. So we've got a bunch of different post herbicides out here. Primarily looking at spectrum of control. I think there is some injury to look at, but we can talk about spectrum of control. Just a reminder that you can always look at the effectiveness tables in the weed control guide to get an idea of spectrum of control also. So we've got velvet leaf out here, a bunch of pigweed, a little scattering of water hemp. We've got several different grasses. We've got 5 different bean genetics, 6 I guess, and then several different corn genetics, which don't necessarily make a big difference, but I'll point out some of the important things there as we go along. So we have 4 plots here to start with that are clethodim, and clethodim, so select and post, and then Gazalvop or Sure, and then fluazafop or Fusilade, which are good grass herbicides. You know, you can find some differences among those, especially when you mix them with other things that reduce their activity a little bit. For example, you tend to see Gazalvop Sure be a little bit weaker on possibly barnyard grass and yellow foxtail. You can also see some differences in volunteer corn when they're mixed with some of the dicamba and 2,4-D products. Here they basically all control the grasses. So you've got the 4 plots, you don't really see much grass. Here they don't have any activity on broadleaf activity. The only difference in the corn, really, they're all especially when applied alone, very good corn herbicides. The second row of corn is the enlist corn. So on my right is, it's resistant to the FOP herbicides, the Gazalvop and fluazafop. So on my right, you've got clethodim and clethodim controlling the enlist corn because that resistance does not confer resistance to the DIM herbicides, only the FOPs. And then you have Gazalvop and fluazafop here where the corn survived. So that's really the only difference here that you can see between these 4 herbicides. We have 2,4-D, in this case Enlist 1, and then Extendamax right next to it. And you can obviously see in the soybeans, so neither of these is really a grass herbicide. You can see a little bit of activity on grass, and when we get to status, you'll see a little more activity on grass from the dicamba. But you got the Enlist bean here, and then 2,4-D causing, I think typical 2,4-D symptoms on the rest of the beans here. Things kind of flipping over. You actually don't see a lot of leaf symptomology here, really, even on the margin. So some growth distortion, things like that. 2,4-D being safe on corn depending on the size. And then it really did take out all the broadleaves pretty well. You find a few small water hemp in here that are surviving. And actually, as we walk through the 2,4-D and the dicamba and the status, there's still some velvet leaf surviving. All those herbicides can be a little bit weak on velvet leaf. In some cases, it doesn't come back. It just kind of sits there and doesn't do much. Next plot is the Extendamax or the dicamba. And in this case, you see the Extendiflex bean and the Extend bean surviving. These plots really do illustrate the difference in tolerance of a bean that's not resistant to dicamba or not resistant to 2,4-D, the difference in tolerance. So you can see on the same time frame, the Extendamax really nailing. I mean, the beans are just gone if they didn't have resistance to the dicamba. And if you come back to the 2,4-D, beans are just generally way more tolerant of 2,4-D than they are of dicamba. So you can see they're still hanging on here. They're not going to probably do much, but they're still hanging on. That is one of the issues that, aside from all drift and volatility characteristics, you're just less likely to see problems with dicamba or 2,4-D movement to non-enlist beans, just because you have a high level of tolerance, and we've demonstrated that in some other studies as well. Dicamba has essentially taken out all the weeds, a little bit of velvet leaf left. You do see a few, again, water hemp. Water hemp, depending on size, you can see it come through both of these herbicides to some extent. Dicamba is safe on corn. And then you get to status. So status has a diflufenzapyr ingredient, which kind of heats it up, allows you to use a lower rate of dicamba and has some activity. What it does is, on top of that, is you can see the Extendiflex and the Extend beans are injured by this because they don't have resistance to the diflufenzapyr component, only to the dicamba component. And generally, you'll see status versus dicamba. You'll see a little bit more grass activity. So if you really looked at these closely, you'd see the grasses are a little bit more stunted here and kind of have that flat stem thing going on. Status generally compared to dicamba is going to have a little broader and a little bit more effective activity across a range of broadleaf weeds. And then it's labeled as for corn as well. So, and again, you do see that the Extendiflex and the Extend bean are actually surviving, right? Versus, the other beans where you know, they're basically gone. You've got the growing point gone and they're dead. You got a few green leaves on there still. So then we get into, I think what's an interesting comparison, we get into, it's always an interesting comparison in these, and we use these plots to train our students for summer weed science contests. And this can actually be one of the more challenging set of treatments to differentiate depending on what kind of beans and corn they plant. So we have glyphosate, and then we have glufosinate. So glyphosate's Roundup, glufosinate Liberty, and all the generics. And then we have gramoxone next to that. And you would think, you know, you'd have a combination of symptomology and spectrum that would make it really easy to tell these apart. And this is actually a set of plots here where it's not necessarily that easy. So what we do in a lot of cases is look towards a margin of plots where we can still see some symptomology. When they all work really well, and they don't always. For example, you know, glyphosate tends to be more consistent unless you have resistant weeds, you know, and glufosinate's just got a little bit more variability, and so does gramoxone. And then once you start to get that variability, you can start to pick apart some symptomology. But I mean, if you look at these three, really across the board, they basically all three of them took out all the pigweed and the grass and everything else that was in here. And you know, we have some yellow foxtail in here, so that's a lot of activity for the glufosinate. Now when you get to the beans and the corn, you know, you can start to pick some things apart. Like so, we've got three of these corns are resistant to glyphosate, right? And you get over here and one of them is not resistant to glufosinate, you know, so you start to see glufosinate won't necessarily kill non-Liberty Link corn, but you start to see symptomology like that, right? It did kill it in the middle, and then on the edge of the plot where you didn't have a full spray, you can start to see some of that typical. And glufosinate and gramoxone are both contact herbicides, and so you're looking for leaf burn and some of those type of symptoms that you really won't see for glyphosate. If you had some glyphosate activity, I'm not sure that really counts, like that, maybe possibly something like that, and that's between the glufosinate and the glyphosate plots. So you may have a combination of symptomology, but you can see the difference between that, where you really don't see any discoloration in the whorl, any light color. It's on the, you know, you can see where you had contact activity on, especially on the outer part of the leaves, versus this, you know, where you start to see some of that. You start to see some glyphosate symptomology down in the whorl because it's systemic. So, and then when you look at the beans, you can see some of the same differentiation where Liberty killed the either killed or injured the beans that don't have Liberty resistance, and then you've got the same thing over here going on with glyphosate. And then you get to gramoxone, which of course we don't have resistance to in corn and soybeans, and this is again for gramoxone quite a bit of activity, but it's a contact herbicide, so you'd be looking for some kind of burn symptoms along the side. But you know, again, these are all very broad spectrum herbicides that, depending on weather and application rate and weed size and things like that, and what type of resistance you have, they can look very similar, or you can start to pick them apart. And then when you have the different beans and corn in here, it just gets easier to pick them apart. So this is atrazine. Atrazine has actually some of those same characteristics where there are times you can apply it and it actually looks like you know, gramoxone. It can be that active. It has a lot of activity here. It's got some grass activity, but you can see it stunted the grass here, which is a little bit out of its window. Atrazine's best on grass, you know, 1 to 2 inches tall with oil at the right rate. And once you start to deviate from that, you're going to start to have grass escape. So you see some grass escaping. We have some trizine resistant lamb's quarter out here, but not a great velvet leaf herbicide. That is one of its weaknesses. Took out the pigweed. Safe on corn. And then you can see not really killing all the beans. You can see, I wouldn't say there are differences among the different genetics. You can start to see some trizine symptomology, which you know, it's basically a contact herbicide when it's applied foliar. So mesotrione, a lot of good symptomology here on the beans. You know, we talked about mesotrione in a previous video. From a pre-emergence standpoint, it has kind of roughly the same spectrum of control post-emergence, but at lower rates. But post-emergence, you do pick up a little bit of grass control, and especially for crabgrass, you can get some crabgrass control out of it. You can see here it really didn't control all the grasses, but you know, kind of took them down a notch compared to sort of this check strip that I'm standing in here. Took out the pigweed, took out the lamb's quarter, good velvet leaf herbicide, and then you can see all the symptomology on the beans. We don't have quote unquote resistance to this to mesotrione in beans, but you can see the row of Gilbert-Link GT27, which has resistance to disoxybutyl, surviving a little bit better than the rest of the beans, which are showing some typical mesotrione bleaching type symptomology. And then this last one is Accent Nicosulfuron, which we really used to use quite a bit more of. It's a grass herbicide that's got activity on a few other broadleaf species. You can see here it took out all the grasses really well. I would say it probably took out some of the broadleaves. If you compare it to the check behind me and the check strip there, you can see it actually took out some. And it does have some activity on others that it just kind of stunts and give you those typical ALS type symptoms like a morning glory. I forget what our rating is for this on morning glory, but you can see it's a systemic herbicide. You get the chlorosis, kind of makes morning glory sort of squat down and stunt and really not do very much. It actually, beans don't have resistance or tolerance to nicosulfuron. Didn't kill them all, but you see a lot of symptomology here. And then safe on corn within limits. It doesn't usually cause symptomology even on big corn. It just starts to mess up ear development and things like that. So that's what we have. Just kind of a reminder of why you use post-emergence herbicides, right? So I think we're in one of those periods now when we've got some really good post-emergence technology for soybeans again, and there's a tendency to leave residual herbicides out. And so, this shows you, I think this shows you why you need both residual and post-emergence herbicides, because that's what that looks like if you don't use any residual. And you can see most of the plots I walk through here, even when you use some type of post-emergence herbicide on their own, you have some weeds coming through. So you're always trying to build a system where the residual herbicides are doing part of that and the post-emergence herbicides are doing the rest. And it also helps mitigate resistance issues as well.